Okay, we're going to do section 6.1b. It's about rational inequalities and being able to solve them. This could be one of the more confusing sections in the book if you kind of go with what they say on Hawks at times or what the book says. Sometimes I feel like that's a little bit more difficult. So I'm going to try to teach you a little bit easier way how to do this. Okay, so try to pay attention. And I think they kind of walk through this in Hawks too a little bit, but let me start by saying we have to solve things like this. Okay, so it's less than, and you're going to have intervals. And you got to say what interval this solves. So anytime you have less than, greater than, less than or equal to, or greater than or equal to, you're going to solve for intervals. Okay, because if I plugged in negative 100, well, negative 100 plus 4 divided by 4 is still less than 0. Okay, so there's a lot of numbers in here that we can plug in that are less than 0. Okay, and that'll range from negative infinity to infinity. Okay, so what will cause this to go above 0? Well, when this is equal to 0, it'll skip above. Okay, or if it had an asymptote, it would move up and down. Okay, so the easiest way to solve this, okay, step 1, find all the asymptotes. Okay, all the vertical asymptotes. That's what really matters. Okay, so you'll find those, and then you get those values. And then what I would do is chart them. Values. And then I chart them on this number line. And then I would just set the top equal to 0, too. Okay, so you're going to set the bottom equal to 0 because you want these values. And then you're going to set the top equal to 0. And you're going to chart every number you get. All right, so let's start with this example. Let's start with the bottom. Set the bottom equal to 0. Now, can it? And the answer is no. Okay, because 4 can never equal 0. Okay, so there's nothing on here that has the bottom. But now let's just do the top. So when is x plus 4 equal to 0? Okay, well, that's at negative 4. Okay, so I'm going to chart negative 4. Okay, so now I should have all the values I can have that makes it skip. Now it's less than. Okay, so it can't equal negative 4, otherwise it is equal to 0. So I'm going to make sure I put parentheses there. These at negative infinity, infinity will also have parentheses. Okay, so I'll have two intervals that I need to check, from negative infinity to negative 4, and from negative 4 to infinity. Okay, now these are not your answers. This is just a whole number line. So it's either going to be this one or this one. Okay, or it could be a combination of several if there's multiple intervals. Okay, so now how I would do it is I would just plug in a number. So negative 5, let's say 0. So I'm going to plug in negative 5, and I'm going to plug in 0, and I'm going to see if it's less than 0. So let's do negative 5 first. So negative 5 plus 4 over 4 should be negative 1 over 4. Is that less than 0? And the answer is yes. So this interval is your answer. And then we need to check this one. So is 0 plus 4 over 4, which would be 4 over 4, which is 1. Is that less than 0? No. So your answer to this question is from negative infinity to negative 4. Okay. All right, let's do a different one. Okay, so now we have 3 over x plus 4 is greater than or equal to negative 5x over x plus 4. Okay, so you don't want numbers here. Okay, so I need to move this over to the other side. So I'm going to subtract it, or since it's positive right here, since this is positive, I'm going to subtract it over. So it would be 3 over x plus 4 minus your negative 5x over x plus 4. These two become a plus, so it's going to be 3 over x plus 4 plus 5x over x plus 4. And notice that these two have common denominators. Okay, so I can combine them. This will almost always happen. Okay, so this denominator and this denominator are going to be the same. So really you just combine the tops, so 3 plus 5x over x plus 4. And this was greater than or equal to, and I move this away, so it's going to be greater than or equal to 0. Okay. Now we have it set up exactly like we had the last one set up. So we need to find all the zeros and asymptotes that we can. Okay, and chart them on this line. So the first one, Set the bottom equal to 0. So x plus 4 equals 0. So the bottom one would be x is equal to -4. I'm going to chart that. Notice that it cannot equal 0 on the bottom. So I'm going to make a chart, or make sure that I put parentheses there. This is negative infinity. That's obviously a parenthesis. In parentheses at positive infinity. All right, so now just do the top. So 3 plus 5x equals 0. Subtract off your 3, so 5x is equal to -3. Divide by 5, x is equal to -3/5. I chart that. Now, if x is equal to -3/5, then the top would equal 0. So it'd be 0 over some number. Can that be greater than or equal to 0? Well, yeah, 0 is equal to 0. So this one is going to be brackets. All right. So I have three options: negative infinity to -4, -4 to -3/5, and -3/5 to infinity. And now all I need to do is check them. So I'm going to plug in points that are in between. So this would be -5. I don't know, -2. And this one could be like 0. Okay, so I just plug those in to this. So let's do -5 first. So 3 plus 5 times -5 over -5 plus 4, which is equal to 3 minus 25 over -1, which is equal to -22 over -1, which is equal to 22. Is that greater than or equal to 0? Yes. So this one's part of my answer. Let's try -2. So 3 plus 5 times -2 over -2 plus 4. So this would be 3 minus 10 over 2. That'd be -7 over 2. Is that greater than or equal to 0? No. And then the last one, you plug in 0. So 3 plus 5 times 0 over 0 plus 4, which is equal to 3 over 4. Is that greater than or equal to 0? Yes. So my solution on this is this interval and this one. So I'm going to write that -3, or negative infinity to -4, parentheses, union, and now this is a bracket, -3/5 to infinity. Good. All right. The rest of them will work out exactly like this. Okay. So -1 over x plus 3 is less than -4x over x plus 3. Move these over. Notice the denominators are the same. So it's going to be -1. I would minus it. So minus a minus would make it plus 4x over x plus 3. And notice it's less than 0 because I moved this over. Okay, set the bottom equal to 0, so x would equal -3. Set the top equal to 0, so -1 plus 4x is equal to 0. I should chart that. Negative infinity to infinity. Notice parentheses on these. -3. Notice the bottom, and it's less than. Okay, so it has to be parentheses on those. Add that over, so I get 4x is equal to 1. Divide by 4, x equals 1/4. That's the other one. Now, since it's less than, it still can't be 1/4. Okay, so my three intervals that I need to check are negative infinity to -3, -3 to 1/4, and 1/4 to infinity. So then I just pick three numbers in between and I'm going to plug them in. So I don't know, -4. In between -3 and 1/4, I have 0 and 1. And again, you can pick any number in between there, it doesn't matter. So let's do -4. So -1 plus 4 times -4 over -4 plus 3. So that'd be -1 minus 16 over -1. That'd be -17 over -1, which is 17. Is that less than 0? No. All right, plug in 0. -1 plus 4 times 0 is 0. 0 plus 3 is 3. Your answer is -1/3. Is that less than 0? Yes. So this interval is the answer so far. Plug in the last one of 1. -1 plus 4 times 1 is 4. 1 plus 3 is 4. So that's 3/4. Is that less than 0? No. So my answer is from -3. 1/4. All right. Okay, so the hardest ones of these, I like this last one, and they're still, they all work out the exact same way. X plus 20 is greater than or equal to x over x squared plus 9. See how they have the denominator is usually the same. Okay. We need to minus this over, so it'd be 5 minus x, and again, since the denominators are the same, I'm just going to go ahead and combine them. X squared plus 9x plus 20, and I'm going to say greater than or equal to 0. All right, number line. And again, I would draw this out every single time you see one of these. Let's do the bottom first. And notice it can't, see how it's greater than or equal to, so the top could equal 0, but the bottom still can't. So it'd be 5 minus x over, I'm going to factor. So two numbers that multiply up to 20 but add up to 9 are x plus 5, x plus 4. So set the bottom equal to 0 would be -5 and -4. And then the top would be 5 minus what is equal to 0, 5. And again, there's -infinity, there's infinity. So we would then pick numbers in between, and we're going to try to solve it out. Okay, so we'll have to plug in 4 numbers here instead of just 3. Let me do that real quick. Okay, so the numbers I would pick, let's say, I don't know, -6, -4.5, 0, 6. Okay, I should have put the parentheses and brackets up here. It cannot be -5 because the bottom cannot be there. It cannot be -4, so that's parentheses. 0, oh, that's what I picked. 5, it can be 5 because 5 minus 5 would equal 0. And then parentheses. So the 4 I need to check are from -infinity to -5, from -5 to -4, from -4 to 5 with a bracket, from 5 for the bracket to infinity. So let's plug in -6 first. Okay, so 5 minus -6. I'm going to keep using this one. So -6 plus 5, -6 plus 4, it's 11, over -1, 4, times -2, so equal 11 times over 2. And is that greater than or equal to 0, which means is it positive? Yes. So this is 1. From -5 to -4, -4.5, so 5 minus -4.5 over -4.5 plus 5, and -4.5 plus 4. So that would be 9.5 over 0.5 times -0.5. So 9.5 over -0.25. So 9.5 divided by negative is a negative. I don't know what the answer is, but this is negative. So is it greater than or equal to 0? So is it positive? No. All right, plug 0 in. 5 minus 0 over 0 plus 5, 0 plus 4. So it'd be 5 and 4. So that'd be 5 over 20. Is that positive? Yes. So is it greater than or equal to 0? Yes. And then 6. So 5 minus 6 over 6 plus 5, 6 plus 4. So that would be 11. 6 plus 4 would be 10. So it's negative 1 over 110. Negative 1. So is it greater than or equal to 0? No. So my answer is a combination of these two. So I'm going to say from negative infinity to negative 5 and from negative 4 to 5 bracket. And that's it. Please let me know if you have any questions on this section.